All right, so section 3.4 is dividing polynomials. Done multiplication, addition, and subtraction, so now we are doing dividing, okay? Just to remind us of the process of dividing using long division, all right, we can look at 83 divided by 6. Okay? What you're first looking at is the first term and seeing if the divisor, if it can divide into the first term, right, which is 8. So 1 times 6, right, gives you 6 here, and then you subtract. Right. You get a remainder of 2, bring down the 3, so 23 is the next one you're trying to find. How many times 6 goes into 23? 3 times, which is 18. Then again you subtract, and we have a remainder of 5, because obviously 6 cannot go into 5. Now, how do we write this as a fraction? Well, we write a remainder over the divisor. So our answer here would be 13 and 5/6. Okay, because remainder over divisor. Now, let's do long division of polynomials. All right, so we're x plus 3. We're dividing x to the third plus 5x squared plus 6x plus 9 divided by x plus 3. Okay. So we want to look, our objective is to first look at the first term and see what we can multiply the first term by to get to x cubed. Okay, so what times x, right, gives us x cubed? Well, x squared. So I'm going to put an x squared up here, right, to line it with the other x squared. And now x times x squared gives us x cubed. We also need to multiply the plus 3 times x squared. So we get plus 3x squared. Now we subtract both of those terms. So x cubed minus x cubed gives you 0. 5x squared minus 3x squared gives you 2x squared. And then bring down the rest. Plus 6x plus 9. Now, right, again, we need to find out what times x gives us 2x squared. Right. So if you multiply by 2x, we'll get 2x squared. So I'm going to write plus 2x here, and I'm going to multiply x plus 3 times 2x. So I get 2x squared from x times 2x, and then 3 times 2x gives me 6x, right? Because I multiply the second term by 2x as well. Okay. Now, right, subtract these, we get 0, and then we also get 0. So now we bring down the 9, right? And obviously x can't go into 9, so this is our remainder. So remainder 9. And how we're going to write this? We're going to write this in as our answer, x squared plus 2x plus a remainder over our divisor. 9 over x plus 3. Right, and that is our solution, right? All right, so let's do another example just to kind of reiterate our thoughts. So again, 8x cubed. Oh, I'll write this a little smaller. 8x cubed. Now, one thing about this, you need to write in plus 0x squared plus 0x. Okay, the reason is because we want to keep it in line. So we're going to kind of plug in a 0x squared just so that we're showing there's a space there. And then we also have another 0x, and then we write our 27. Okay, so this is important to make sure you write those missing terms. Okay, so it goes 3, 2, 1, 0 essentially. We're going to divide this by 2x plus 3. Again, right, just like before, what times 2x gives us 8x cubed? Well, 4 times 2 gives us 8, and then x squared times x gives us x cubed. So 4x squared. Then, right, we need to multiply both terms times that. We get 8x cubed from 4x squared plus 2x, and then plus 12x squared. And then we subtract them. We get 0, and then we get negative 12x squared plus 0x plus 27. Okay. Now we're looking what times 2x gives us negative 12x squared. So negative 6x, right? Negative 6x, right? Negative 6x times 2x gives us negative 12x squared. And then 3 times negative 6x is negative 18x. Then we subtract them. We get 0, and then we get positive 18x. Right? Because it's minus and negative becomes positive, plus 27. Now, what times 2x gives us 18x? Well, plus 9, right? 9 times 2x gives us 18x. And then again, we need to multiply by the other term. 3 times 9 gives us plus 27. We subtract, and we get a remainder of 0. Therefore, our solution is just what we have up here, 4x squared minus 6x plus 9. Right? Because there's no remainder, we don't have to write a remainder over the divisor. All right, so what I want you to do is try these ones on your own. So I'll kind of set it up. Right, x cubed minus 6x squared plus 11x minus 6. We don't have to write in any zeros because we have all the terms. And now this one you're dividing by 3 terms. Right, so make sure, right, you're trying to find out what times x squared gives you x cubed, and then you need to multiply all 3 terms by that number, or that term. Next one, right, 16x to the 4th, but we also need to add in plus 0x cubed plus 0x squared plus 0x minus 85. Then divide by 4x squared plus 9. Okay, so pause this, try this on your own, and then we'll go through it. So here's our solutions. You can check your answers on these. All right, now what we're going to do is a different type of division. This is called synthetic division on polynomials. Okay. So what is synthetic division? Synthetic division is a method of polynomial division with a divisor of x minus a, right? Meaning coefficient of x equals 1 and the power equals 1 as well. So, right, you can see if you look at the example x minus 3, see it's x minus a number, right? It could be x plus a number, it doesn't matter, right? As long as it's x's coefficient is 1 and it's to the first power, we can use this thing we called synthetic division, okay? All right, so how do we do it? Well, I'll go through the steps. What we're going to do is first make a backwards capital L, like this, right? And we're going to write the coefficients of each term. Of each term of the polynomial, right? So the polynomial we're dividing by, we have a 2, we have a 7, we also have a plus 0x, and then we have a minus 4. Okay, and we're going to write this to the right of our backwards L. Okay, so I'm going to write a 2, negative 7, a negative 4, a 0 and a negative 4. Okay, now in our backwards L, right, this is where our A term goes, right? A is equal to 3, right? The reason is it's because it's x minus A, right? So x minus 3 equals 0, so x is equal to 3, right? So whatever you see, if it's x minus 3, you're going to put a positive 3 there, because technically your A is equal to 3. If it was x plus 3, right, it'd be a negative 3 in that backwards zone. And then we're going to make a line down here. And then we're also going to make a dash right before the last term. Okay. The reason is because this will be our remainder. Now, what you're going to do is step 2 is we're going to bring down the first coefficient. Right? And then we're going to multiply that number by our A term, right? And put it under our second coefficient. Then we're going to add that row. Okay, so right, here's our original 2, negative 7, 0, negative 4. All right, so like I said, we're going to bring down the 2. Now we're going to multiply 3 times 2, right? Which is 6, and I'm going to write that under the negative 7. Now I'm going to add these two. Okay, so multiply, add. So negative 7 plus 6 gives me negative 1. Okay, right. This negative 1 comes from negative 7 plus 6. This 6 right here came from 3 times 2. Right. Now, step 3 is to repeat the process until all columns are full. Right, so I have my 3, 2, negative 7, 0, negative 4. right? From the last time we had a 2 here, a 6 here, and a -1. Now I'm going to multiply 3 times -1, right? And I'm going to get -3 here. Then add my 0 and 3 together. I get, sorry, -3, we get -3. Now I'm going to multiply this -3 times 3, and that will go here, which is -9. And then add these together, and I get -4 plus -9 is -13. Okay. So this is my remainder. And step 4 says these are the coefficients of the solution. All right, so this is the last one is our constant. This is x, right? And this would be x squared. So our solution is 2x squared minus 1x or minus x minus 3. Well, I guess we could say minus 13 over x minus 3. Right, because this is our divisor, right? Remainder over divisor. You could leave it as plus 13, plus -13 over x minus 3 if you want as well. So you can try this on your own if you want, but I will go through it right now. All right, so my a term is +1. My coefficients are 3, 0 for x plus 0x squared, minus 5, plus 10, right? And then I'm going to make my dashes. Okay. Bring down my 3. 3 times 1 is 3. 0 plus 3 is 3. 3 times 1 is 3. -5 plus 3 is -2. -2 times 1 is -2. So I get 8 here. So, right, this is my x squared. This is my x. This is my constant. And this is my remainder. So my solution is 3x squared plus 3x minus 2 plus 8 over my divisor of x minus 1. All right, so once you kind of, I know the steps seem long, but once you kind of get the hang of it, it's actually not too bad. All right, lastly, we have the remainder and factor theorem. The remainder theorem says if a polynomial p of x is divided by x minus a, the remainder is p of a. Meaning, right, if you substitute in what your a value is into the polynomial, right, for all the x's, essentially, that gives you your remainder. Okay. So I get to substitute. Value of a in for x in the polynomial. And the result is your remainder. Right, that's essentially what this is saying. Now, right, if your result was 0, right, then you just don't have a remainder. Right? That means it perfectly divides in. So that's the remainder theorem. Then we have the factor theorem. Right, the factor theorem says when you perform the remainder theorem and p of a equals 0, right? So factor theorem means that you get a result, right? Result equals 0. That means it is a factor, right? So if we get a result of 0, that means it divides evenly perfectly with a remainder of 0. And that means that we could actually factor out that binomial that we were dividing by. All right, so let's go through an example of how to use the remainder theorem. First, right, find a. Right, so x plus 2 equals 0, so x equals -2, or a equals -2. Right. Then substitute a equals -2 and for all x's. Okay, so p of -2 equals 2 times -2 to the 4th plus -2 squared minus 10 times -2 minus 1. Right, so we get -2 to the 4th is 16 times 2 is 32. -2 squared is positive 4. -10 times -2 is positive 20 minus 1. So our remainder is equal to 55. Right, so essentially, right, just get x by itself. That counts as your a term. Substitute in, and whatever you get for your answer is your remainder. Now, right, let's use the factor theorem. So essentially, you need to do the remainder theorem, and if it's equal to 0, it's a factor. If it's not equal to 0, then it's not a factor. All right, so our a is 6 here that we're going to test. So I'm going to substitute in 6 for x. So 6 to the 4th minus 8 times 6 to the 3rd plus 16 times 6 squared minus 23 times 6 minus 6. Okay, so we get 1296, and then we get minus 1728 plus 576 minus 138 minus 6. And if you combine all those together, it comes out to 0. So, because it's 0, yes, x minus 6 is a factor. So you could actually factor out x minus 6 from that polynomial, and you get another polynomial. All right, let's try the next one. All right, a is -3, so we're going to substitute -3, so p -3, -3 to the 5th minus 5 times -3 cubed plus 9 times -3 squared minus -3 plus 3. All right, so we get -243 plus 135 plus 81 plus 3 plus 3, which is -21. So no, x plus 3 is not a factor. Okay, so what I want you to do is try these on your own. Then you can pause it, and then you can check your solutions. I'll show you solutions. Here's the solutions. A, you get a answer of 0.
when you substitute in 4 to the equation, right? Because your a is 4, so yes, x minus 4 is a factor. The next one, when you substitute negative 5 in, it does not equal 0, it equals 5, so it is not a factor.